Hello, everybody. I'm Herbert Wolfson. I'm going to be talking to you a little bit about Rust for game developers. Thank you so much for inviting me to the GameDev Mini Symposium. We're going to cover quite a lot of material, so I'll move forward at a pretty good rate. There'll be room for QA at the end. We'll start by looking at what the Rust language is. Then we'll discuss a little bit about how it can help you and why you should consider it. Then we'll look at a couple of scenarios for actually benefiting from it. One is building a game with it from the ground up. We'll look at a roguelike for that. And the other is integrating it into your existing engine workflow. So to get started, who on earth is Herbert Wolfson? I'm a consultant working for Bracket Productions. That's my company. I use the same label as an indie game developer. I've recently been working on Nox Futura, One Night in the Dungeon, an Unreal 4 engine roguelike, SecBot, Tech Support the Roguelike, and Apocalypse Taxi were all 7-day game challenges. I always find that to be a nice, relaxing way to spend a week. You come up with an idea, try desperately to make it work in a week, and see where it takes you. And each of them have been pretty different. SecBot was kind of a traditional roguelike, except you shoot things. Tech Support had no fighting at all. You just ran around solving people's IT problems, trying not to run out of coffee and not to be demoralized by managers. And Apocalypse Taxi is all about randomly building cities and seeing what I could do with them. My other job is that I write books. I recently released Hands-on Rust, Effective Learning Through 2D Game Development and Play, and you'll see a few examples from that book in my talk today. I'm about to release Rust Brain Teasers, Exercise Your Mind. It's in tech review right now. Hopefully when it comes back, we'll make some improvements and get it into beta on pragprog.com very soon. I also work for the Pragmatic Publishers, who published my book. I am their Rust series expert, so if any of you have the burning desire to publish something about Rust, feel free to drop me a line, and it's my job to help make that happen. So what is Rust? Rust is a systems language. That means it compiles to fast native code. It's open source, so it's the work of thousands of people all combined, with a few steering committees trying to keep it in roughly the same direction. Its syntax, as a result of this, combines bits of ML, C, C++, C#. In fact, if you're used to C, or Java, or C#, or ML, you'll find plenty to keep you you'll find plenty that you're comfortable with. And the same is true with Haskell. You really can approach it as an imperative language or a functional language. It's not really an object-oriented language. Despite that, it looks a lot like C#, but without the classes. It has a lot of use of iterators to transform data from one format to another, map them, and do all that good stuff. Now, it isn't object-oriented, but it does have a system called traits, which can be used much to do the same thing. A trait is basically an interface that defines what an object promises that it can offer, and then you implement the traits as needed. And Rust is ubiquitous. Firefox, the browser, uses Rust for a lot of its security-critical code and some of its rendering. The Android operating system uses Rust for Bluetooth, and Google's new Fuchsia operating system is mostly written in Rust. Amazon Web Services actually use Rust for their backend provisioning, and Amazon have been very big on funding and joining the Rust Foundation that guides the process. Microsoft is starting to use Rust in Windows and Azure. And most importantly to me, Rust has a cute crab named Ferris as a mascot. So how does Rust help you with game development? Well, games tend to be very performance critical, so building fast, low-level code is very important. Rust is very good at that. Everything that you can do in C, you can do in Rust, but with a baseline safety level that's quite a lot higher. Rust tries its best to stop you from shooting yourself in the foot. Memory safety is the first form of safety that Rust provides. Basically, it makes a whole lot of common C-style memory errors impossible. So you can't use a variable after you free it or move it. Accessing references unsafely in such a way that the reference might cease to exist will not compile. Buffer overflows are pretty much impossible unless you go into some unsafe marked code and do it on purpose. Memory leaks likewise are possible, but they're really difficult to accomplish unless you use a rather bizarre built-in keyword that lets you forget some memory. Another big win for Rust is fearless concurrency. The Rust language knows all about threading right down to the compiler, and it keeps track of how you're sharing data between threads. So if you're doing it in a way that doesn't synchronize and will cause a data race, that's actually a compilation error. And this makes using threads easy enough that quite often people do it without even knowing that they've multi-threaded their program, which is a big change from what you can do in C or C++. Now, from time to time in Rust, you'll see the unsafe tag. Basically, that lets you do everything that you can do in C, but it clearly labels the parts of your code that might be a problem. So the potentially dangerous memory operations that you know will work, but Rust can't prove as safe, get wrapped up in unsafe, so when it comes time to audit your program, you at least have the dangerous parts clearly labeled. Cargo is a package management and build management system. Basically, Rust has a big dependency system built right in, a huge growing library of packages, which they call crates. You can find anything all the way from Vulkan to obscure text management, and it's growing rapidly. It's a little bit better than NPM in the sense that it's managed and they try to make it harder for you to accidentally hurt yourself with it. But it's really nice and reassuring to have it, and because it works on every platform Rust works on, you can be pretty sure that your program will compile on any platform you aim it at. Lastly, Rust has first-class interoperability. It makes it very easy to link other programs into Rust or Rust into other programs. So instead of throwing out the baby in the bathwater and rewriting everything in Rust, you can quite easily pick a chunk, write that in Rust, and then link it into your main program. We'll look a little bit more at that in a moment. Now, I got started in Rust after working on One Night in the Dungeon for a long time and running into memory concurrency issues. So I asked around what are the cool kids using, and they told me I should take a look at Rust. I did, and I started out by making a traditional text-based roguelike. I actually recommend that as a first step for trying out a new language. They're relatively simple. You can keep adding to them. And testament to that you can keep adding to them is that my tutorial started out as a little 5-chapter how to do it, and all of a sudden there's 74 chapters, and I'm working on the 75th. So this is pretty much a step-by-step guide to making a traditional ASCII roguelike. Unlike some, it uses an entity component system architecture, and you'll see that a lot in Rust because it's very easy to handle concurrency and memory safety with it. Basically, you're separating it out so that your data is stored in what's effectively an in-memory database with joins and queries, and then it makes it relatively easy to architect your program so that different parts are running concurrently. Of course, with a roguelike, sometimes things are very serial, so you need to take that into account as well. For example, there's no point in processing damage before you hit someone with an axe. My tutorial veered off into adventures in procedural generation. You can see a drunkard's walk operating in the bottom right there, busy building up a map. Basically, this simulates a drunken dwarf running randomly around the map, digging holes everywhere he encounters. It's a great way to make nice organic looking maps. If you're interested in more ways to do that, then I highly recommend checking out the tutorial. Now, when I started working on hands-on Rust, I wanted to give you a fun way to learn the language. And so writing games is fun, playing games is fun. So the second chapter in hands-on Rust builds Flappy Bird, the game you see at the top there. It's pretty simple, and you can do it in 200 lines of Rust. They're 200 pretty productive lines, but there's really nothing there that you look at and say, well, this would win an obfuscated C contest. In fact, the book walks you through it all in one chapter. By the end of the chapter, you've got a nice playable game. The second game you see at the bottom there uses the Bevy engine and is also 200 lines of code. It was really pretty simple to throw together the logic to have rows of baddies and a ship at the bottom that moves around and shoots, all using an ECS setup. So Rust is great for taking a source code first approach, building the game you want. It also supports publishing to WebAssembly or native code or Android, so you can build your program and run it on multiple platforms with very little in the way of source code changes. Now, I've talked a lot about entity component systems, so I'd like to talk a little bit about them in the context of a dungeon crawler. Excuse me. You've probably run into game designs where you have an object tree. So you might have a base object, say game object, Underneath that, you might have monster, and then derived from that, you'd have orc, you might have dragon, you might have dwarf, and so on. ECS kind of turns it on its head, and it's much more like an SQL database. So an entity is just a unique ID number. And then every entity is composed of a set of components. And the idea of components is that you can reuse them. For example, a position component would define where you are on the world map. And the great thing is that almost everything is going to have a position component. So code that you write that works with it once will work over and over again. Likewise, a render component tells the game, what do I put on the screen? And then you can start to combine things. So you might come up with an enemy type component. Well, this links into to an AI system that makes enemies roughly track towards the player. And you might decide that you need to differentiate between enemies who shoot and enemies who have guns. So you add a melee component. And now the melee system will check, is the monster next to the player, and if so, bash them. You might want a dragon, so you add on fire breather. Now, what if you decide at some point that you want a fire-breathing orc who punches things? Well, the great thing is now you've got three components, you can combine them all together, and your system's code just works, or at least most of the time. One example I like to give was in Nox Futura. Everything had a position in 3D. The map was all nicely defined, everything could move around. Creating a gravity system, everything could suddenly fall to the ground. And they did. Even axes and everything else that wasn't actively being held up, everything just worked. And that was quite fantastic, with the exception of the birds I'd implemented, who instantly fell to their death. So entity component systems take a little bit of getting used to. If you're familiar with Unity, apart from trying to patent it, they've been adopting this model. I don't think their patent is going to go anywhere because they themselves cited prior art in this field, which is pretty dumb. But basically, you define everything up into entities and components, and then systems work by processing that data in a database style. And resources are basically global variables, shared data that you want to share across your program. So you put all that together, and you start to get a nice a nice manageable setup that you can quite easily continue to expand. And you can also cut and paste your systems from previous programs and reuse them. Now, systems, particularly in Rust setups, are really, really powerful. So looking at the example at the bottom there, that asks for to create a query that lists everything that has a position and a render component. And what you get from that is an iterator that goes through every single entity that has those two components and the contents of those components. Make them mutable, you can change them. Those are set to be read-only. And that would be useful, for example, if you just wanted to find out where everything is, put it on the screen. Systems can have multiple queries if you want them to. You quite often do. They're best divided into small chunks that do one thing well. Quite often you'll find yourself doing something in a system and actually flagging the relevant data that you want to do something else with in another system. Now, in the major Rust ECS systems, Legion, Specs, and Bevy, that we'll talk about in a moment, you gain one additional thing from this. Because the system defines the queries, the ECS system is able to look at the queries and say, okay, well, you're not writing to anything, so you can run concurrently with any other system. Or it can say, these two are writing to render, so they cannot run together because you might get into a data race. And so the great thing is it's able to take all of your systems and build an execution graph. In fact, sometimes you find yourself having to add phases to prevent things from running concurrently because you want one to depend on the data of the other. So here is the roguelike in hands-on Rust. When it's the player's turn, usage of items and combat run concurrently. Movement runs on its own because it relies on too many other results. Field of view is calculated as soon as the movement finishes. There's no point in calculating what you can see and then promptly moving. But then at the very end, it concurrently renders the map, entities, heads-up display, and does some logic to finish the turn. So at any given time, you might be using four cores on your computer to render this roguelike and make sure that everything stays nice and zoomy. Likewise, the monster turn actually is able to do its AI, random movement, and chasing logic concurrently, and then goes through the very same systems as the player. ECS really does promote code reuse, so it's a nice, efficient way to work on your projects. Now, Rust is a relatively new language, so it's just starting to get some engines together. I've talked a little bit about Bevy. Bevy is a 2D and 3D engine. It's currently very good in 2D, and, well, it's getting there in 3D. It's very popular for making games like the 2D shooting gallery that's illustrated there. It is ECS all the way up, so it defines some components, you add them, and things appear on the screen. It's currently almost entirely code-based, so you write out your source code and the program runs. The Space Invaders demo in 200 lines was written with Bevy. Now, there is a Bevy editor coming. It's not done yet, but it's getting there. I don't want to try and give you an ETA, but they are making leaps and bounds, and eventually you'll have something more Unity-like where you can start dragging objects onto the screen. But it's not there yet. Other engine definitely worth a look is RG3D. They took the opposite approach. They started with a 3D editor, and they started tacking on more and more scripting and code control, and now you can produce pretty beautiful looking first-person shooters like that. They've started releasing guides on how to make RPGs and generally more general gameplay. They're absolutely intending to make this into an all-purpose 3D engine, and it is starting to look beautiful. So RG3D is definitely worth a look if you feel like taking that approach. So games that have been made with Rust, valorem is probably the poster child because it is a huge voxel-based game similar to Minecraft in the sense that you can destroy everything, knock everything over. It's also massively multiplayer. You can have 64 people connected to the same server running around, playing together in the same voxel world, making use of Rust's pretty amazing async and networking capabilities. It's a great showcase for what you can do. It uses a package called WGPU, WebGPU, so it can compile to a web page, though currently that doesn't work because browsers don't always get threading right. But it can also output to Vulkan, OpenGL, Metal, and DirectX 12. On the right is a good example of a Bevy game, Whack a Frog. It's relatively simple, pretty graphics, 2D, definitely the sort of thing you can throw together in Unity. It's also quite a short program and uses a little demo of what you can do. If you go to the website, Are We Game Yet? They have hundreds of examples like this. Now, another way to use Rust to help your game development is to integrate it with other engines. Godot is probably the poster child of this, because with one plugin, Rust becomes a first-class citizen. You can write your scripts in Rust. The library integration is fantastic and pretty much covers everything that the C++ API can do. It's full of helper macros to stop you from having to write long repetitive code. And best of all, from inside the Godot editor, you can actually manage your Rust scripts, test them, debug them, and then if you really want to, you can mix in some other languages as well. In the bottom right, somebody was playing with a Factorio type game, managing your supply chain with boxes moving everywhere. That's one of the free examples showing you how to integrate the two. So all of the game logic is being done in Rust. All of the rendering and object management is being done in Godot. Unity can also be integrated with Rust. You see this less commonly for actual game logic because C# is honestly a really nice language. However, C#'s memory requirements can get a little strange. And so I've started seeing quite a few cases in which Unity is linked with Rust for things like generating procedural content, sometimes even doing heavy math and making meshes. Or if you have simulation that's going to use a lot of memory, has to balance things out, and you really can't afford to have the garbage collector come along and kill everything. You can write some Rust, compile it to a DLL, and integrate it into your Unity build. There are tutorials for doing this available for free. It is gaining popularity, and it's getting easier. Right now, it's still a little more code than I'd like to write, but it works. Integration with Unreal. A few people have asked what's the point, because Unreal already has C++. So at this point, honestly, you're down to, well, I prefer Rust. So you can create libraries in Rust and import them into UE4 and UE5. It's starting to get popular for some of the network code because the C++ standard networking library is a mess and really won't start looking good until about C++ 25, I think. I haven't seen it so much for procedural generation, but it could do that. Right now, it's early days, and you're probably, if you're in Unreal as your main engine, you probably don't need Rust right now. All right, and that concludes my talk. You can reach me as @Aberticus on Twitter, the bracket on Reddit. My website is handsonrust.com with dashes there. If anybody has any questions, I'd be happy to take them.